let's go ahead and get started about what's going on. I've gone back and looked at the first two assignments that were due, and a lot of people struggled on a few things. I want to go back and look at one of them just to give you some tips. And I went back and I've changed the settings on those assignments where you can go back and redo ones you missed. You can go back and edit that. But let me put up on the screen like the second assignment here. So this was lesson 2 assignment. And like here's the first one: directions for the following set of data, determine whether it's linear, quadratic, or exponential. And most people did pretty well in this, but what if you don't know just by looking at this table which one it is? Like, okay, well, I don't know which one that is. Well, that's when you go to Desmos and just click and make a table and graph it. You can take a look at it that way, right? So if you had, remember, you can make a table if you go to Desmos when you click on this button, table, and just put all your X's and Y's here and let it graph those for you. So then when it graphs those for you, you know what it would be then. So you can do that and determine if it's linear, quadratic, exponential. And then what was the best fitting equation? So let's look at that. Let's go ahead and fill this in. So this goes from -5 to 0. So if we did -5, -4, it'll fill in the rest of those automatically for you. And then it's 7.9 and 2.7, 7.9, 2.7. Let's look at it. -2.6, -2.6, -7.8, -13, and -18.3. -13, -18.3. All right, so I've plotted those points now, taking them straight to Desmos. And what I'm seeing is that looks very linear. That's very linear, right? That's a line. And next thing it asks for is what's the best fitting equation to the nearest thousandth. And that's where some of you guys messed up too. Thousandth. There's tenths, hundredths, thousandths. That's 3 decimals, thousandths. Best fitting equation. Remember, we can use Desmos and say, okay, since I know it's linear, normally linear would be y equals mx plus b, right? But we're going to use our table data. This is an x1 and a y1. So I got to put a 1 after the x and put a 1 after the y. And instead of an equals, because it's like, I don't know what it equals. Remember, we're going to use that tilde, that over in the top left of your keyboard, that tilde right there. So when I do y1 tilde mx1 plus b, now it will give me a best fitting line, the line that fits my data. And there's my m right there, and there's the b right there. So the m is -5 point, remember it said thousandth, 3 decimals, 237, because the 1's going to make that 7 round down. And then the b is -18.276, because the 2 is going to make that round down. So don't forget, you got Desmos to use right there that can help you fill in what is that best fitting equation. Once you see that it's linear, ask it for a linear using that little tilde and using the y1 and the x1. There's also a video in Google Classroom that goes over how to do that. All right, so yeah, remember, you can go to Desmos, and I do have a video in Google Classroom, if you look at last week, that tells you how to do this for linear, quadratic, and exponential. It's like a 10-minute video that goes through Desmos and shows you how to do all 3 of those. So don't forget that. This one of the basic mistakes I saw. So here's a table that has the average sales price, which is Y. Y is the average sales price, and that's in thousands. So that's 184,000, 154,000. And for various years since 2002, X. This is how many years since 2002. So that first one is the year 2002, then that must be 2004, and that's 2006. But this says use a quadratic model. It tells you right here in the question to use a quadratic model. And yet some of you tried to use something different. You wrote an equation for a different type of model. So for this, you'd want to go to Desmos again, and you'd want to change this data. You want to make a new table, get rid of that table, close it out, and make a new table with the new data. And then you'd want to change this to be a quadratic model. right? So that'd be ax1 squared plus bx1 plus c, right? That's quadratic, ax squared plus bx plus c, but use the x1s and the tilde, and it would create a quadratic equation for you on that. Now, again, this information here doesn't fit a quadratic equation, but you'd want to do the ax squared plus bx plus c and let it do that. So, all right, but it says use a quadratic model. And then you're supposed to use your formula above. So you use this exact expression, and it says the nearest thousandth again. Find the average sale price for a house in 2016. So you'd have to look, well, how many years is that since 2002? Well, that's 14 years. So you'd want to take 14 and put that in for X in your equation right there, in that equation. Put 14 in there, and then put in an answer right there, rounded to the nearest tenth. So just one decimal. You put that in there with the 3 decimals, put in your 14, and then round that to the nearest tenth. So some people struggle a little bit with the rounding. Some people didn't use a quadratic model and a few other things in there. So if you messed up, you can go back and fix those, because I've reopened those to where you can go back and edit when you have things wrong. So that'll give you a chance to go back and do that. And I'm going back, and some of you guys that were just a rounding error, I'm giving you most of the points, stuff like that. So I haven't gone through them all yet. So if yours hasn't been updated and you were close, you were just off by rounding, don't worry, I will get to it today and get those updated. And then I will get them put in your home access center, because I don't have any grades in there yet, because I got to get all these graded first. So we will do that. So, all right, let's look at this week. If I go to Google Classroom, let me put that up on our screen so we can look at that real quick. Bring it over here. All right, 5th hour. What do we got under classwork? All right, this is the week of September 5th through 9th. This is week 4. So lesson 3. All right, we've only got one lesson, but we also have a quiz this week. So we have lesson 3 assignment and a quiz over the first 3 lessons that we've done here. So here's the notes to use for class. Again, if you have a printer, I try to put these in there where you can print off these notes, or if not, have a pencil and paper so you can write down notes, because you need notes for this. And then I have some extra information down here. I try to give you extra stuff. Like if you have a TI-84 and you want instructions on how to do a residual plot, I've got those directions right here. If you want to use Desmos to create a residual plot, I've got a video right here. It's just a 1-minute video on how to do a residual plot. And what is a residual plot? I have a couple of videos you can watch. This is just a 2-minute video. This one may be 6 or 8 minutes. I don't remember, but it talks about residual plots. So if you don't understand what I'm explaining, these videos would be good for you to go back and check it out and help you understand what a residual plot is. So if you don't understand what I'm talking about today, look at these videos and then come back with questions, and I'll be happy to help you. But we have one lesson and the quiz today. So first, let's go through the notes. All right, so here's our notes, and I've got those printed out. So I'm going to put those up here on the screen. And we're not going to go through all of the notes because we don't have that much time, but there's all kinds of good stuff that'll help you walk through these things. And we're just going to pick out some of the sample ones and do this, but all of these have printing on the back too. So we got lots of notes, and then place for extra notes if you want to. So, all right, but I do want to start here on the front because it's kind of a review of what last lessons were, and we need to make sure we know how to do this for the quiz today. This week. So this says Stella, Jasmine, and Brandy went on a road trip, and every so often someone wrote down how far they'd traveled in minutes and how far they had traveled in miles. So this is their time in minutes and their distance in miles. It says they each plotted the data pairs as points in the coordinate grid. So here's their points, and they all have the same points. They all have the same points in there. And then they each determined a different line of best fit, a linear equation to model the data, a regression line, right? So they each went, and they're each just a little bit different. If you look at it, you got this one's got a slope of 1.04, this one's got a 1.09, and this one has a 1.03 with a 0 y-intercept. This one has a y-intercept of -2. This one has a 3.46. And they want to know which one best fits this data. Which one? They're all very, very similar. You can see they all look like they would be a pretty decent average line of best fit. But looking at it, how can we tell? Well, just trying to eyeball it, this one, there's several points to the right on it, and the ones that are off are a little bit high. So it's not really in the center. This one looks, that has a point or two that's high, a point or two low. That looks really close. This one has one that's really close. This one's off just a bit farther. It makes me think this one might be the best one, but we can check this again with Desmos. So let's go back to Desmos real quick and put that up on our screen. And let's make a table for that. Let's cancel this old data, make a new table, and I'm going to use the information they just gave us there: 30, 62, 85, 124, 151, 185. Okay, that's their table, and their distance they went was 30, 65, 102, 130, 165, 190. So then we should have the same points they had. And once I zoom out far enough, there's the same points that they just had. Now we can ask Desmos, since we know that's linear, again, y1, use the tilde instead of the equals, mx1 plus b, mx plus b using the x1. This says the 1.034 and the b of 4.366. Let me write that down. So it says an m of 1.03422 and a b of 4.36659. All right, so comparing that to what they had, this one has a 1.04, 0.3466. This has a 109 minus 281 and a 1.03x. So this one's just a little higher slope. This one's rounded down just a little bit lower, which that's what I'd round to, but it's off on the B, right? The B should be at about a 4.36. This is the closest one to what Desmos would have done with that, because it's closest for the y-intercept. See, this one's a negative. This is a positive, so that's way off. The -2 is quite a bit different than the +4. This one's pretty close to that. And the 1.034, and they said 1.04. So this would be, of the ones they gave us choices of, that would be the closest using Desmos on that. So, all right, just remember how to do that on Desmos, because that saves you a lot of time and guessing, and you don't want to do a lot of guessing. There's those calculator directions I have on how to make residual plots. So we're going to talk about residuals today, and what is a residual. So let's look at this graph here. Here's some points that were plotted, and then they did a line of best fit, making a linear line. What do you notice in there? What do you think? Looking at their line of best fit. Is that a good line? Did they do that well? Y'all a quiet bunch here. Give you that long weekend. No, Haley says that's not a good line. Shouldn't have been linear, it doesn't look like. What would have been a better choice? Because the linear regression line just doesn't work. Exponential, absolutely. Yeah, good job. Exponential. I see you guys putting that on there. Yeah, that's an exponential line. So I think an exponential regression line would have been a lot closer to matching those points in there. So that's not very accurate. Not very accurate at all. So that's a terrible line of regression. So they want us to, on the back of this, next page, generate scatter plots, and they gave us 4 different sets of data. Now, I'll tell you, we're going to skip that step, because the next page is they've already done it for us. But first, if you have trouble making scatter plots, this is good practice to do that, making a scatter plot. But here we are, we have a page that already has the scatter plots. So if we look at these, this one obviously linear. I mean, it's almost perfectly linear. It may be. I mean, it is right there. This one primarily looks linear. I mean, you got some points to be, but if we did a line of best fit, it'd probably be somewhere right through there, and we have some a little bit higher and a little lower, but about the same distance higher and lower. So that'd probably be okay. This one, well, it's kind of linear, except there's one outlier. This outlier here may really kind of mess up a linear one. And then this one, we look at, okay, that looks very exponential. Exponential growth just almost perfectly. All right, so we can see that and makes observations about that. So the next thing is they tried to put some linear regression lines. And it kind of confirms what we was talking about. That one's almost perfect. Every one of them are almost exactly on the line. That one's off just a little bit. It looks like that one may be just a touch low, just a touch off, but very, very close. That's somewhat, it's not a tight linear, but it's somewhat okay. This one, again, kind of thrown off by the outlier, kind of pulls the line up a little bit to where it's off of some points. And this one, way off of that. All right, so we kind of saw that looking at these points before we had it graphed for us. But if we look over here, now they want us to take these, this is the same data, and they want us to write a linear regression equation. So let's pick one of these, and let's make this a linear regression equation for it. Let's look at, oh, how about this one? This looks interesting. Let's use this one and make us a linear regression equation. So they gave us the spaces, and it tells us up here, we've got to pay attention, nearest 10th. Nearest 10th. All right, so I'm going to go to Desmos, and we're going to enter this data into that graph. All right, so let's get rid of that. Make us a new table with the information they gave us. 0, 1, 2, 4, 5, and 7. And then the data they gave us is 0.2, 2, 1, 4.8, 4, and 7. All right, now let me zoom in there because we're zoomed way out. Okay, that looks like the points that we had. Okay, there they are, kind of spaced out nicely. Let's make that linear regression line they want. Using the tilde, mx1 plus b. Okay, that's the line. It's looks like the line that they had. And here is the m and the b. And it told us to round to the nearest 10th. So our m was 0.919617. The nearest 10th would just be 0.9. And then the b is 0.25. The 5 tells us to round up. So we would make this a 0.3. So let's go back and look at that now. Oops. Where'd it go? There it is. Okay. So yeah, use my blue marker, make it better. So our regression line would be y equals 0.9x plus 0.3 would be our y-intercept. Now, taking that a step further, on the back of this, now we're getting to what this week's lesson is about. Residuals. I'm going to highlight residuals up there. Residuals. What is a residual? A residual is the difference between the actual, I'm going to highlight actual, and the predicted y values. Okay, we know the actual y values are right here in our table. And we find the predicted one by using that linear regression equation. So complete the tables below to find the residuals for each. Right, so let's go back to write our equation up here so we know what our equation was. It was y equals 0.9x plus 0.3. So no, make sure I'm using the right data here too. We're using the 4.8, 4 in the 7th, this one down here. And our equation was y equals 0.9x plus 0.3. All right. So we need to plug in the values we have right there. Put a calculator up here so we can make sure we get this accurate. And we're using it plus 0.9 and 0.3. predicted y. So we got to plug in x. We got to plug in x. So if x equals 0 in our equation, 0 times 0.9 is just 0 plus 0.3. So we would expect, using our equation, that this would be 0.3. All right. How about when x is 1? 1 times 0.9 would just be 0.9. So 0.9 plus 0.3. So we would expect it to be 1.2. All right. So we can continue to do that with each of these. 2 times 0.9 would be 1.8 plus 0.3. So it gives us a 2.1. 4 times 0.9, because our next x is 4, equals 3.6 plus 0.3. So we expect this one to be 3.9. Our next one is when x is 5. So 5 times 0.9. Oh, I think I missed the point. I did. 5 times 0.9 plus the 0.3, 4.8. And then finally, 7. 7 times 0.9, 6.3 plus the 0.3. So this is using our regression equation, using, I'm going to leave that calculator up here for a few minutes. This is our predicted y using our regression line, using the equation for that line of best fit. So now we got to the point where we can calculate the residual. Remember, it says the residual is the difference between the actual and the predicted. So to find the residual, we just take the actual and subtract the predicted from it. Okay, so our first residual, the actual was 0.2. If we subtract 0.3 from that, we got negative 0.1. That's our residual when x equals 0. 2 minus 1.2 is 0.8. 1 minus 2.1, we got a negative residual there, negative 1.1. 4.8 minus 3.9, 0.9. 4 minus 4.8, negative 0.8. 7 minus 6.6 is a 0.4. All right, so we see all of the residuals are pretty close to 0. Right, this one's 1.1 away from 0. This is 0.9 away from 0, but all the others are closer than that. Negative 0.1, just 0.4. So they're all pretty tight to 0, which means our line isn't too bad because the residuals are all very close to 0. Now, I will show you a nice little shortcut. Now, it doesn't work here because it told us to round to the nearest tenth. But if we weren't rounding, let's go back to the Desmos graph that we built for this. Desmos will actually calculate those residuals for you. Now, it's going to use all of these decimals, so it's not going to be rounded. But if we hit plot, it calculates, here's all the residuals. 0.05, 0.82, 1.09, 0.8. See, these are all really close, just like the ones we calculated. We calculated 0.9, negative 1.1. And if we turn off the y's and just look, here's the plot. I want to turn off that line also. Here's the plot of these residuals. And we can see they're all pretty close to 0. I mean, they're just a little bit, there's 1, so not too far off of 0 all the way. And they're pretty evenly spaced out, which tells us that's not too bad of a line. When we looked at this R value over here, it was 0.94. Remember, the closer that is to 1, the better our line is. So we knew it should be a pretty good line. But you can actually hit that plot button and it will calculate residuals. But again, this is not rounded. We had to round to the nearest tenth. So ours is going to be a little bit off of this number, but not exactly. So that is a residual plot. And when we see a residual plot that's that close, then we can be pretty confident that we're about in the right place there. So that's pretty good. That's over here. Okay, don't have anything over there I need. All right, let's go back to look at our notes here. Okay. Using that equation with that data, we get all of our residuals. So that's important. That's what our lesson is this time, is on residuals. So you need to understand that. So here is another sheet which just uses the other two. So there's a blank for all four of these. So if you want to go back and practice more of this, which would be a great thing to do, go back and practice and look at this. In fact, this one, I think, let's go ahead and look at this one, because this is the one that looked like it shouldn't have been linear at all. But so let's go ahead and put this into Desmos, and I want to do it a linear equation for that one using that information. So let's make a new table using the information from this last table, 2, 4, 6, 8, and 9. Okay. 1, 2.25, 4, 7.5, 17, and 38. All right, if we zoom out a little bit, at 38 ways up there. But there is the last plot they had, and it said this make a linear regression line, which we know is not going to be very good because it doesn't look linear. So there is the linear line that they tried to fit that data with. So if we round that to the nearest tenth, it's going to be 3.4 is our M, 3.4, and our B is negative 4.8. Negative 4.8. Not necessarily a good fit, but that is what they wanted us to try. So doing that, and then going to our second page here, the predicted Y. The predicted Y using this equation. And that's the same data, making sure I have the right chart there. Let's look at our predicted Y on that. So getting our calculator back up here. Did I close the? I closed the calculator. Let me reopen it. All right. Well, the first one's when x equals 0. So we can do that one really easy because 3.4 times 0 is 0. So it just leaves us with negative 4.8. How about when x is 2? So if we do 2 times 3.4 is 6.8 minus 4.8. So that should be 2. Now, when x equals 4 times 3.4 minus 4.8, 8.8 is what we would expect there. When it's 6 times 3.4 minus 4.8, 15.6. Now when it's 8 times 3.4 minus 4.8 is 22.4. And when it's 9 times 3.4 minus 4.8, 25.8. All right, so looking at our residuals using that equation, actual minus predicted, 1 minus a negative, so that means 5.8. 1 minus a negative means we're going to add. 2.25 minus 2. Well, that one's pretty good. It's just 0.25, right? 0.25. 4 minus 8.8 is minus 4.8. 7.5 minus 15.6 or negative 8.1. 17 minus 22.4. And 38 minus 25.8, we're looking at 12.2. Now, if we compare that to what we did on the other one, these were all very close to 1. Most of them were less than 1, being away from 0. There's only one of them that's even close to 0 here. These are all very large numbers. The residual's way off of that. So if we go back and look at Desmos again on that and let it plot the residuals for us, let's get rid of the original one. Like, we are a long ways away from the 0. Way up here above 12. We're down here below 8. Very far off of it. If you look at the plot looks non-linear of the residuals. The plot of the residuals looks non-linear. And that tells us right away that, oh, we've done something wrong. This does not match linear at all, because the graph of the residual plots is not anywhere close to that. So that gives us some good clues that a linear model is not very good for that. And here's the residual plots graph, where they say pictures can help us see that. So create a visual of these residuals. Again, Desmos just did that, and we saw this one was very high like that. When we did the other one, it was really close. Let's go ahead and plot real quick. This gave us the same residual numbers. These are the same ones that we calculated. See that? Same ones that we were calculating using that nearest tenth. So we plot that, 0.1 be right there. 1.8. 2 is a negative 1.1. 4 is a 0.9. 5 is a 0.8. Oh, negative 0.8 should be in here. My bad. And 7 would be 0.4. So scratch that one. That's not one. But we see they're all very close to 0. When this one we saw they jump way up here and way down, and they're way off of there. So residual plots, the visual of that can help you understand if you've got the right regression line. Do you have the right kind of line in that? So good stuff. So looking at that, let's take our notes. All right, scatter plots that are perfect linear relationships have blank residuals. Well, if it's a perfect linear relationship, our residuals are going to be 0, right? Have 0. All of them will be 0 if it's perfect. If it's perfect linear, all of them will fall exactly on the line. The expected will be exactly the same as the actual, and we will have that. And the residual plots show all points on x-axis, all right? Because if we plot them, they'll all be on 0. They'll all be on the x-axis if it's a perfect linear relationship. If it's a strong linear relationship, it'll have, right? This one was not, but this one was a strong linear relationship. It's very close. So it's going to have small residuals, right? And the residual plots show all points close to 0. I'm going to put x-axis. Right? All the points are going to be close to 0 if it's a strong linear relationship. All right. Scatter plots that are weak linear relationships, it is still somewhat of a linear. It's just not really tight, kind of like the one we saw where there's some of it that's higher and lower. We'll have, let's say, small-ish. And the residual plots show evenly spaced points above and below. Right? It may be evenly spaced points above and below the x-axis. It'll be spaced out a little bit farther. Like if we did the plot these points, I mean, these are going to be a little bit off either side. This one is a little weaker. It's a weak linear relationship. It is somewhat linear, but it's weak. But you're going to have points above and below if we plot those. See, these are going to be negative, so they're going to be below the x-axis. This is going to be a positive above the x-axis. You're going to see Larger numbers, they're not as small. They're small-ish. They're not like 30 and 40. Still pretty close. This one's off by about 1, 2, 3. So that's going to be about just less than 3. It's going to be about 1. It's going to be 1 and a fraction somewhere in there. And then scatter plots that are nonlinear relationships have large residuals, which we saw with that last data. The last one we had when it has 5.8 and 12.2 and -8. And the residual plots show nonlinear relationship. We'll say it that way. Because we saw that it didn't even look linear. The plot, the residual plots did not even look linear. It showed a big curve on the residual plot even. So that was looking at that right there. See, that's not even linear. That's a nonlinear right there. So, all right. So that was the main points we wanted to get into. We got extra notes. There's some more practice right here for your notes. In your own words, explain what a residual is. That might be good to put in your notes. We've talked about what a residual is. We gave us the official definition, and it's the difference between the actual and the predicted and how to calculate it. But if there's some way that helps you understand that better, that you can put in your own words, you can do that. And here's 2 data sets for your notes here. This is in the handout in Google Classroom. Here's 2 residual plots. Which one is a better linear fit? Explain your reasoning. Well, this one we see, this is the residual plot again. This is not the actual data. This is the residuals. This is the x-axis. These are all pretty close. They're above and below. Here's the x-axis for this one. We see again, this doesn't even look linear. Doesn't even look linear. Now, this is closer and tighter to the x-axis. So that's closer to a line, and this is way off. So this is a terrible linear fit. This is not a linear data. We would need to use a different model for that than what we have there. So, all right. I want to look real quick at our lesson, the assignment we have this week. So here is Unit 1, Lesson 3 assignment. So I'm going to go through this. You can click here to get Desmos. You click that, it'll open up Desmos for you in another window. All right, so you can use that table right there and create your information. And you can always zoom in on this. It's got this little zoom in thing in it. It'll bring it really big on the screen where you can see what it's saying. So here's a residual again. Here's that definition. Difference between actual and predicted. And then complete the tables below to find the residuals. So first, you have to figure out what is the linear regression equation, just like we did before, to the nearest 10th. So that's what number 1 you have to fill out. You have to say, what is that equation? Because if you don't know what the equation is, it won't be able to figure out any residuals. You have to be able to predict that. So, all right, I hit escape, and that'll unzoom that. So the first thing you do is you enter your equation right there, and there's where your y's and x's, and you can put all that in there. Enter to the nearest 10th, your y equals mx plus b. And it tells you it's linear right there. So once you do that, and I would make a table on paper so you can keep track of all of these. There's make this table on paper so you can keep track of that and fill out all of these using your equation. When x is 0, what is your predicted y? When it's 2, what's your predicted y? 4, 6, and then the residual, actual minus the predicted. All right, so you put all of those in here, predicted when x is 2, 4, 6, 8, 9, and then what's the added residual? Okay, then you get down here. It says plot the points from the given table. Okay, when you click show your work, it'll open up this screen. Here's the same table, so you don't have to go back and forth. I put the same table right here, and there's where you plot them. Put these points, x and the residual, so 0, 5.8. You can choose a scribble. You can choose your color you want to make your points. You want to make them red. You want to make them pink and purple, whatever you want to make them. All right, and then you just put your points on the graph for these 6 things right here. And it has the question over here too, if you need to refer to that. And then after you do that, the last question is based off of your scatter plot. This is the plot of the residuals. Which statement's correct? It's a perfect linear relationship. It's a strong linear relationship. It's a weak linear relationship, or it's a non-linear relationship. And that would be the last one. So that is lesson 3. That's the assignment. Again, it's all about residuals. You have to be able to do that linear regression equation, that line of best fit from our earlier lessons, in order to be able to do this. Because if you get off on that, then these are all going to be off. So round to the nearest 10th, 1 decimal. All right. And then looking at the quiz. All right. Again, it has the link to Desmos. If you need to use Desmos, the link is right there at the top of the quiz. And then it has questions for this. In which equation is the relationship linear? It gives you 4 equations. Which one of those is linear? And if you can't tell by looking at that, you can always graph those 4 and see which is linear. But you should be able to look at the equation and tell which one of those is a linear equation. Which one of these is quadratic? Remember, quadratic equations have one thing different than everything. They always have an x squared. Which is an exponential? Growth. See, there's 2 exponential equations right there, but one of them is not growth. One of them is decay. Choose the relationship that best describes the values in the table. If you look at that and you can't tell, I don't know if it's linear, I don't know if it's exponential. Go to Desmos, put those in a table. Look at it. You can always go look at that. Graph those. That's why I give you that link to Desmos right there, so you have that available. Again, here's another table. Which one of these? Here's another table. Which one of these? Then this one gives you a table, and the table's this way instead. There's still the x's and the y's. Is it linear, quadratic, or exponential? Then they want that best fitting equation in that again. Best fitting equation. And I'll go back and add. I forgot to put on rounding in there because you'll need to round it. I'll put where to round it to. Either tenths, hundreds, or thousands. I'll go back and look and see what I was looking for there. Remember, tenths is 1 decimal, hundreds is 2 decimals, thousands is 3 decimals. So you'd put that in there. And then this tells you to use a quadratic model. So you're going to put this in your Desmos table. Here's your X, your 0, 1, 2, 3, 4, 5. Here's your Y. Use a quadratic model. And remember, there's a video in Google Classroom. If you don't remember how to make a regression line that's quadratic, go back and refer to that video. So after you do that to the nearest 10th, then use that to find the approximate number of new subscribers in 2021. Right? And it gives you the years right there. So you're expanding the table. If the table went all the way to 2021, what number would be the number of new subscribers? And then the last problems down here is a residual again. This gives you, and let me zoom in on it, this gives you the linear equation right here. Here's the equation used. Here's the line of best fit. All you have to do is take this x, plug it into the equation, and give the predicted value for each. But it's already got the same equation for everybody to use right there. So here's the x values. Put in the x and put the predicted value. And since this has tenths, your answer is going to have a 1 decimal. It's going to be to the nearest tenth as well. So you'll do that for those 6 and then calculate the residual value. So again, I would make a table on paper so I can keep track of this and make sure I got the right numbers in the right places. Subtract actual minus predicted and give the residual value. So it gets down here, the residual value when x equals each of those. Then the last question is, does the residual numbers above suggest a linear relationship? If you look at those residual values, does that suggest it's linear? All right. That is the quiz that goes after the lesson 3. Quiz, our first quiz there. So, all right. Any questions? Everybody understand that? Makes sense? See what we got to do? We're just adding residuals this week to what we already learned last week when we learned how to do the regression lines. Remember, I've got videos on how to do the regression lines. I've got videos this week on talks more about the residuals. So there's always lots of help in Google Classroom. If you still have problems, come and ask me Thursday. Come and ask me Friday. This week, we have 3 B days this week. Today, Thursday, and Friday. There's only 1 A day. Tomorrow's your only A day this week. So come see me Thursday or Friday if you have problems with this. I want you to do well in the quiz. I want you to understand it. Don't get there and get lost and just give up. Come see me. Say, I'm stuck. I forgot how to do this. I looked at the videos. I still don't understand it. Walk me through it. And we'll walk through and make sure you understand how to do this. But that is it, guys. I will let you go. I know these classes are going to be long because we've got a lot to cover in here, but I want to make sure you have all the tools you need to be successful. And go back to those first 2 lessons. If you mess things up, go back and look at those and fix those, because I've got that where you can go back and edit your answers and do that better. So, all right. Have a great week. We will see you later.